Welcome to the next chapter, chapter 11 of 11th Physics, Thermal Properties of Matter. In Thermal Properties of Matter, you will study about the properties of different substances by virtue of which heat is transferred. You might have noticed that you feel hotter on a sunny afternoon as compared to a windy night. This is because of that temperature difference. Temperature is very high in afternoon as compared to night. In simple terms, we can say that when temperature is more, heat is more, and when temperature is less, heat is less. As shown in the diagram, the two examples, the first one is of hot sunny day when the temperature is more, and the second one is ice cold water where the temperature is less. So temperature is the measure of degree of hotness or coldness of a body. For example, a cup of hot soup or a scoop of ice cream. Heat is a form of energy transferred between two or more systems or a system and its surroundings by virtue of temperature difference. For example, a cup of hot coffee can be considered as object or system, and anything apart from hot coffee is surrounding. Then the heat will flow from one object to another as there is a temperature difference. And after some time, you will see this hot cup of coffee will become cold as there will be transfer of heat. SI unit of heat is Joule, and some of the commonly used units are calorie and kilocalorie. And 1 calorie is 4.18 joules, whereas 1 kilocalorie is equivalent to 1000 calories. The SI unit of temperature is Kelvin, and some of the commonly used units are Fahrenheit and Celsius. Here is the difference between heat and temperature. Heat is a form of energy, whereas temperature is a degree of hotness or coldness. Heat is a cause, whereas temperature is an effect. SI unit of heat is Joule, whereas the SI unit of temperature is Kelvin. Two bodies can be in thermal equilibrium without having the same amount of heat. But two bodies cannot be in thermal equilibrium without having the same temperature. Heat is a measure of total kinetic energy of all molecules of the body, whereas temperature is a measure of an average kinetic energy of all molecules of a body. Flow of heat is independent of an amount of heat energy contained in the body in thermal contact. But the flow of heat is dependent on the temperature of two bodies. It flows from a body at higher temperature to the body at a lower temperature. Thermal expansion is the phenomena of increase in dimensions of a body due to increase in its temperature. Examples of thermal expansion. Sometime you might have observed that the sealed bottles with metallic lids are so tightly screwed that one has to put the lid in hot water for some time to open the lid. This would allow the metallic cover to expand, thereby losing it to unscrew easily. Another example, in case of liquids, you may have observed that mercury in the thermometer rises when the temperature is put in a slightly warm water. If we take out the thermometer from the water, the level of mercury falls again. Similarly, in the case of gases, a balloon partially inflated in a cool room may expand to full size when placed in warm water. On the other hand, a fully inflated balloon, when immersed in cold water, would start shrinking due to contraction of the air inside it. Here is the reason why this thermal expansion occurs. When any object is heated, particles start moving in random motion, and thus average distance between the molecules increases, and as a result, the object appears to be expanded when heated. As we can see in the diagram, atoms are tightly packed, but when we apply heat, they will start moving in the random motion.